We're going to continue solving systems, but now introduce another method to solve them, and this is called the addition or elimination method. Recall that the substitution method enabled us to replace one of the variables in one of the equations with an expression so that we had just a single equation and a single variable to solve. This is what the goal of this method is as well. That is, we want to eliminate one of the variables from the two equations. And the way we will do this is we'll add the equations together. And the only thing that we can do is multiply one or both of the equations by some non-zero number so that we get coefficients that are opposite to one another. So we want to make sure that each equation in the system is written in the same standard form. That is, the variable terms on one side, the constant on the other. If the equation has any fractions or decimals, we want to clear those out. Then we will multiply one or both of the equations by some non-zero number to get the opposite coefficients. Add the equations, solve that resulting equation, and then substitute to find the value of the other coordinate. And again, we can check. So let's look at this process. We have the system 2x plus 3y equals negative 16 and 5x minus 10y equals 30. So you have to make a decision. Do you want to eliminate the x or do you want to eliminate the y? And it really doesn't matter which one you choose. Sometimes one is easier than the other. But my goal, let's just say I want to eliminate the x. So if I'm eliminating the x, notice that if I add the two equations in this form, 2x plus 5x is 7x. So that does not eliminate that variable. I need to find a common number that I can get to by multiplying, and that is the least common multiple. So I think about what number is the least common multiple of 2 and 5. Well, that is 10, right? And so I need one of my coefficients to be a positive 10x and the other to be a negative 10x. And again, it doesn't matter which of the order you choose, if the top one or bottom one is positive or negative. So let's just say I want to make the positive 10 on the top. So I think, well, 2 goes into positive 10 5 times. So I need to multiply that first equation by positive 5 to get a positive 10x. And when we distribute, we will get 10x plus 5 times 3y is 15y. And then 5 times negative 16 is negative 80. Now my second equation, I need to think, well, 5 goes into negative 10 negative 2 times. So now I need to multiply the second equation by negative 2 so that I can get a negative 10 as a coefficient of x. So I distribute to get negative 10x. Negative 2 times negative 10 is a plus 20y. And that's equal to a negative 60. The common mistake I see is students forgetting to multiply the right side of that equation by that number. So be sure you carry that distribution through. Now that we have opposites, we're going to add our equations together. 10x plus negative 10x is 0, right? 15 plus 20y is 35y. And negative 80 minus 60 is a negative 140. So we can divide negative 140 divided by 35, is that negative 4. And so now I have my y, I need to figure out what x is. So this time I have to use one of the two equations and substitute negative 4 in for x, and for y and solve for x. So let's just use the first equation. So we have 2x plus 3y equals negative 16. In place of y, I'm going to put negative 4. So this gives me 2x plus 3 times negative 4 equals negative 16. Simplifying, 2x minus 12 equals negative 16. And then we can add 12 to each side to get 2x equals negative 4. And then divide by 2 to get x is negative 2. So my solution is the ordered pair negative 2, negative 4. Again, if I wanted the solution set, I would put it in the braces. Okay, and again, that's not two separate values. That is a single solution that consists of the ordered pair x, y. Now, how do I know I'm right? Plug it in. So if I say 2 times -2 is -4, plus 3 times -4 is -12. -4 plus -12 is -16. 5 times -2 is -10. -10 times -4 is +40. -10 plus 40 is 30, so it does check. In our next example, we have the system 2x plus 2/3 y equals 5 and 2y equals -6x plus 15. So the first thing I want to do is get these equations in the same format, get them in standard form and clear fractions. So in my first equation, I'm going to multiply each side by 3 because I want to eliminate the fraction. So that's going to give me 6x plus, well, 3 times 2/3 y is just 2y, is equal to 15. Now in the second equation, I need to get the x and y term on one side. So I actually need to add 6x to each side to get it on the left. And that would give me 6x plus 2y is equal to 15. Now I can't add these two equations in this form. The coefficients are not opposite. If we want to eliminate the x term again, I need to figure out, well, what is common between 6 and 6? Well, that is 6. But I need one of them to be a 6x and one to be a -6x. So we'll keep the first equation as is, 6x plus 2y equals 15. But then we need to multiply the second equation by -1 to make it a -6x, right? So that would give me -6x minus 2y equals -15. And again, this one has something very unique happening. Notice that 6x minus 6x is 0. 2y minus 2y is 0. 15 minus 15 is 0. So this is a case where the variables are eliminated and we have a true statement. And what this means is that there are infinitely many solutions of that system. In fact, you can see it in the original form, or that is after I got them in the standard form, that those two equations are exactly the same. So this is the case where the two lines are the same. So they're the same or coinciding lines, which means that every single point on the line is a solution. So the way we write that, we can't list them all, so we actually write this in this form. So we say the set, and then we put in parentheses of the ordered pair x comma y, and then draw a vertical line, which we read as such that, and then we just say such that 6x plus 2y equals 15. This notation means that any ordered pair that satisfies this equation is a solution of the system. So remember that the parallel lines were indicated by the fact that we got both the variables eliminated and a false statement. But if both variables are eliminated and we have a true statement, then that is the case of the same line. So be sure you know how to do both the substitution and the elimination method to solve systems.